In this lab, we are asked to practice writing and testing a class. So we're going to be making a class in here. We have to write a SmartStringList class with the following methods. So we are going to make a new Java project, title it Lab 13, and we will go inside of here and make a new package, and then make a new class that is called SmartStringList. So this is what our class is going to look like. First thing we're asked to implement is a constructor. It constructs a list of given max capacity. We have our code here also, and we're asked to use an array internally. After we write the instruction and our method here, it's going to look like this, and we can start implementing things. So we need to construct a list given capacity. So we can actually go outside here. Our first one is going to be a private string, and we're going to call it ARR for array. We're just initializing this array. We're not giving it a size yet. We will soon. But this is an array. When it has these brackets, it means it's an array of type string, and that's the name for it. And then after this, we are just going to set array equal to new string, and then the size. So now our array is the size of our capacity. Our next part is to have a public void add string s. And what this is going to do is add the given string to the end of the list. We need to have the ability to check where we are in our list. Since we just made our list right here and there's nothing in it right now, we're obviously at the 0th index. So what we can do is make a variable that holds that index and then increments it every time we add something into the list. So we're going to do private int index, and then in our constructor, we're going to go in here and we're going to do index and set it equal to 0 like this. That is declaring it and then initializing it to 0 temporarily, so that we can go in here and make an if statement and say that if our index is less than arr dot length, and this gets the length of the array, then what we're going to do is write code in here to add it to the end of our string. So this is just checking if our index is in our array length. If our index is bigger, we are going to have an else statement that's just going to say list is full and string cannot be added. In our if statement, we're going to have to add our array in. What we can do is just set our current index equal to s. It's setting for this first run in the if statement. For when we're adding our first string in here, it's going to be array index 0 is equal to s. That's going to set the first index to s. But we need code that increases this index every single time, so we're not overwriting our code. So what we're going to have to do is write index plus plus. If we look back at the instructions, notice that we have to have the list in a sorted order. So in here, we can actually check if the array is sorted or not. What we can do is write an if statement in between here and say that if our index is greater or equal to 1, that means if there's more than one string in our array, it's going to do this. We're also going to have an and case, and array, and we're going to have our current index. So if this is running let's say that we have a second string in here. We have our first string and our second string is added. Like if we look at these, obviously our first string is bigger than our second string. So what we're going to do is we are going to compare these two. So we have the array index, which will be the current index. So if we're looking at string 2, it's going to be the first index because string 1's the 0th index. We need to compare our current index to our previous index, so the index to the left of it in our array. We have to use the dot compare to method, and we're going to ignore the case in here. If we click this, it'll autofill it out, and we are just comparing our current index to our previous index. So inside of our compare to ignore case, we are going to have array index -1 to get the last index, and that is going to ignore whatever case it is because we're not comparing cases, we're just comparing length. Now we need to know what our compare to ignore case does, and we have two parts of it. We have this left part and we have this right part. And the way compare ignore case works is it goes from 1 to 0 to -1. Basically what this is saying is if this object is greater than this object, it's going to return a 1. On the flip side, if these are both equal, it's just going to return a 0. And on the total flip side, if this object is greater than this object, it's going to return a -1. For our code, we want to make sure these are in order by length. That means our current index has to be greater than our previous index. That means that this index has to be greater than our previous index. So it's going to return a 1. However, we can check if it's less than 0. We're going to say that this is not sorted and we have to sort this. We can say if it's less than 0, then it's not sorted. And in here, we can state that our array is not sorted. To do this, we're going to make a variable up here and we're going to make it a boolean. So it's also going to be private boolean, and we're just going to say sort. And we're going to initialize this as true. If our array ever becomes out of order, it'll go into this if statement and set sort to false. Then we will have to organize it later. And we are going to go back in our if statement and set sort to false. Because if our value that gets returned is less than 0, that means this index is greater than our current index. And if our previous index is greater than our current index, then our list is not in order. And we're just going to do index ++ to keep iterating, going up one index so we don't overwrite our previous index. This is it for our add method. Now we are going to be in our get method. In here, all we're going to do is return the string at index I. So we are taking a integer as our parameter and we are returning this index. We need to first check if the parameter that we're given is greater than the indexes we have in our array. We're just going to return array is not this large, try a smaller index, like this. And if we do have an index in here, we're just going to have an else statement that returns this. And that is it for our string get method. Next, we're going to look at our index of method. What this does is return the position of the given value. So it's basically the opposite of what we did last time. We were given a index and we were returning the value at the index. Now we're giving a value and we are asked to return the position of the given value. In here, we need to check if our array is first sorted, and then if our array is sorted, we can return the true position at which our value is at. Otherwise, we have to sort things and switch which values are paired to which indexes. We're going to have an if statement. We're going to say if our Boolean sort is true, then we are going to find this value. So if it is sorted, we can come in and find this value. We're going to use a binary search. And instead of writing all the code in here, what we're going to do is just make a separate method that will run this. So we can call it binary search, set it to S, and then return whatever our index is. So we need to make a binary search method now. We're going to make it public, type int, and title it binary search, which takes the parameter of string s. This is going to be our method, and we can call it a helper for index of. A binary search needs a minimum, a middle, and a max value. So we can make our min and our max out here. Our minimum value is always equal to 0. Our max value is going to be equal to our max index, which, since we're incrementing index every time we put a new string in here, it's always going to be incrementing. So index is going to equal our max value. And we're going to do this while our min value is less than our max value. And inside of here, we're going to set a middle value. So do int mid is equal to min plus max divided by 2. And then we need to compare this string to our current mid value. We're going to have int current equals s dot compare to, and then we are going to compare it to the value at our middle index for our array. If both of our values are the same, we can return the middle index. So if current equals 0, then we're just going to return mid. However, if they do not equal 0, we're going to have an else if statement, and we're going to say if current is less than 0, that means that when comparing these two, our value here was greater than our left value, because we have 1, then it goes to 0 if they're equal, and then -1 if this one's greater. So if this one is greater, that means s is less than our middle value, and we have to make a new maximum value. This maximum value is going to be our current middle minus 1. So we need to set our max value equal to mid minus 1. And then we're going to say else, but what this is really doing is we're basically saying that if current is greater than 0, we're going to do something else. So if our current is greater than 0, that means our value on the left is bigger than our middle value. If this is true, that means in our binary search, when we have our min, our mid, and max, since s is greater than mid, we're not going to look at these values. That means we're going to have a new minimum. This is our new minimum, mid plus 1. So our new minimum is going to be mid plus 1, like this. And we're going to keep going until our current value is equal to 0, or until these two equal each other. And then we are going to break out of our while loop. If we cannot find this string in our array, we can't find the index of it, we're just going to return if the string is not found. So we're going to return -1. And that is our binary search. And this is only for if sort is true. If sort is not true, we're going to have to sort them ourselves. So we have to make an else statement. This is back in our index of method. Going back here, and we have to perform a sequential search and then sort our values. We're going to make a new index, and that is going to be sequential search, and we're going to pass in the parameter s. Then we're going to call our sort method to sort this, and then we're just going to return idx. Now we need to make a sequential search method to look through this. So we can do that under our binary search method, and we can make this smaller so we can still see our index of method. Here we're going to have public int, and we can just copy this sequential search, and it's going to take the parameter of string s. In our method, we're going to go through all of our values until we find this string. So we need a for loop, and we're going to have int x equal to 0 as long as x is less than or equal to index. And then we're just going to increment x each time so that we can eventually break out of our loop. In here, we're going to do an if statement, and we're going to say if our string s dot equals, and we are going to ignore case, so we're going to do the second one, and we're going to compare this string to another string, ignoring case considerations. The two strings are considered equal, ignoring case, if they are the same length, and corresponding characters in the two strings are equal, ignoring case. This returns true if the argument is not null and represents the equivalent string to string, and false otherwise. In here, we are just going to have our AR and then the current index. So if s, the string passed in, is equal to the value at the current index, we're going to say this is true. And if this is true, we're just going to return x. That is the index at where we are at. If it's not true, we're just going to return a -1. And that is our sequential search method. We can make this smaller so that we can also write our sort method now. We can see that we actually needed a sort method anyway, so this is not going to be a helper. This is our method, no parameters in here, and we're going to say that it puts the list in sorted order if not already. Now that we have this, we can start working in our sort method. If someone calls this sort just by itself, not going through these things, we have to decide if our sort is true. So we're going to write if sort is equal to true. We're not going to do anything. We're just going to say the list is already sorted. And then we're going to break out of our method by using return. If it's not sorted, we have to sort all of these. To do this, we are going to use a selection sort. It's going to have our string of values. What it's going to do is during the first run, it's going to compare all these values, find the smallest value, and switch it with the first value. So now this is going to be like this. And then it's going to go through the array again, and it's going to swap the second smallest value with the next index, which would be this. It would do this again, and since this is already organized, it won't switch anything, and then it will break out of the for loop. So to do this, we need to go through all of our indexes. We're going to have int x is equal to 0, as long as index -1, because we don't have to compare the last thing, since like we said, it'll already be the highest value will be in the last index, since all of the other values are sorted. And then we're just going to increment this every single time. We need a minimum index, so we're going to say int min is equal to x. And then after this, we are going to have another for loop inside of here. That way we can compare all of our values. We're going to call it y, and we're going to set it equal to x plus 1, so we can compare the next value. And we're going to do this as long as y is less than index. And then we are just going to do y plus plus to increment it every single time. In here, we need an if statement to compare things. We're going to say if our array at the yth value, and we're going to compare this while ignoring the case to our minimum index. And using our compare method, we are just going to make sure that it is less than 0 to get in here. If this is true, basically what this is saying is that our minimum index is greater than our current index. If this is true, we need a new minimum index. So we're going to store our new minimum index. We're going to store the index y if this value is less than our current value, because that means this value is smaller. After we do this, we compare all of our indexes to our first index, the first current index. We have to swap our new minimum value with the older index. And then we can make a swap method for this. We're going to do this inside of our last for loop, but right outside of our inner for loop. We're going to make a new method called swap, and we're going to pass through our array. So we're going to pass through our ARR. We're going to pass through our minimum value, and we're also going to pass in our current index that we are comparing it to, which is x. Now we need to go outside of here and make a swap method. We're going to set this to public static void, calling it swap. And our parameters are int AR. Oh, for our swap method, we don't need to include the brackets here. And then we also have our int min and our int x. This is our swap method. First, in here, we're going to swap the minimum index, which is our x value. Our x value is currently 0, and our minimum value is whatever the smallest value is. So we are swapping our smallest value with whatever value is at the front. We need to assign a temp to be our smallest value. So ARR x, that's going to store our smallest value, because we are going to set the smallest value to be our minimum value. Or we're going to set our smallest index to be our minimum value. We're swapping these two. We're swapping whatever index is at the front or whatever x is at the time to be our new minimum value. And from here, we're going to do array. The new smallest is going to equal our temporary value. Oh, and this should not be an int. This should be a string since our array is of type string. We need to change our temporary value to string, and then everything should work out fine. After we swap everything, we're going to break out of our last for loop. If we keep doing this over and over, we're eventually going to break out of here, and then we can just say that our sorted is now true. And then this is our entire method. So this is our current class. We probably made some errors somewhere. So we are going to review everything and make sure everything works out and test it by using a main class and calling this class. So first we have our variables. What this one is doing is creating a string array named ARR, and we are setting the length of that string to whatever capacity is put into our list. Our index is going to be 0. It starts at 0 because our list is going to start at the 0th index if nothing's added into it. So now our index is equal to 0. Our first method is that we need to add given string to the end of the list. We take a parameter s, and this is whatever string that needs to be added into the list. We have an if statement in here, and this is basically saying if our index is less than our array length. So this is just checking to make sure our index is not greater than the length of our array. If it is, we can't add it in here because our array is full. If our array is full, we're going to be in our else statement which just says the list is full and string cannot be added. If our list is not full, we are going to go into our if statement, and we are going to set whatever the array is to string. So index is currently 0. We're setting our 0th index to whatever the passed in string is. Next, since our rubric said that it needs to be in order, we need to see if the next string that's going to be added in is in order. So we're basically saying if the index is greater than or equal to 1, so if there is one or more strings, and a compare method has two parts, the part on the left and the part on the right. And if the part on the left is bigger, it's going to return 1. If they're equal, it's going to return 0. And if this part's bigger, it's going to return a -1. What this is basically saying is that if our previous index, so string 1, if this is bigger than our index that we just put in, that means it is out of order. It'll return -1, which is less than 0. And if it's out of order, we're going to have to sort this later, since the length of string 1 is greater than string 2. And to prevent our values from writing over each other, we have to increment index by 1 every single time. Our next method returns the string at index I. We have a public string method called get. We're taking the parameter int I, and if I, the index passed in, is greater than our index, we have to return that the array is not that large and we need to try to smaller index because we can't look at something that's not in our array. If it is a possible index, then we're just going to return the value at that index. Our next method is a more complicated method, and it returns the position of the given value. Our if statement executes if sort is true. So if we are in our add method and we add all of our strings in and they're all sorted, if they're all sorted by length, then we are going to be in this if statement, and all we're going to do is search for our value and return its indexed. We do this by using a binary search, and in our binary search we take the string s as a parameter and we perform a binary search that looks like this. We need a minimum and a max value, and we have a while loop that's going to run as long as our minimum is less than our max. We also have a middle value inside of here that is going to change every time we run this while loop. And starting our loop, we're going to say that our current value, and we're going to compare the string that's passed in to our value in the middle of our array. If they're equal, it's going to return 0, and then we're just going to return the middle index because that's what it is. And then IDX is going to restore the middle index. If it's not, we are going to have to continuously binary search until we find the index at which our value is stored at, or return -1 if the string is not found. If it's not found, then IDX is just going to contain a -1. So we've gone through our if statement, which had our binary search. Now we need to look at our else statement, which has our sequential search and sort methods. First, we're going to look at our sequential search, and what this is doing is it is storing the index, the current index, of whatever the string S is, whatever it's passed in. We're going to look at every single index until we can find this value. To do this, we have a for loop, and we're setting x, the temporary x, to be less than or equal to index, so it evaluates every single index. We have an equals ignore case in here because we're not looking at the casing. We could, if we wanted to, we would just get rid of the ignore case and have equals. And we are saying if s is equal to the value that is at the current x index, then this is true. And if it's true, it's going to return x. If not, it's going to keep going through this loop until we have reached the last index, which is stored at index. If we go through this entire loop and we don't return anything, that means we don't have this value in our index, and we're going to return a -1. So if this returns -1 or a specific index, it's going to store it in IDX. Before we go into return, we have to sort our array since it's not sorted, and it asks for it to be sorted. We can collapse our sequential search method and look at our sort method. Since this is a method, it can be called when we are running our main program, whether through index of or by itself. So we have to say if sort is equal to true, we're going to print out the list is already sorted, and then just return to break out of that. If not, we are going to use selection sort to solve this problem. And we're going to use a for loop encased inside of another for loop so we can examine all of the values. Our first for loop is going to get the current index, which is 0. It's going to get the 0th index. Our outside for loop is going to get our first value and store it in min. And then our inside for loop is going to compare all of the values in our array to this minimum value. What it's going to do is compare, using the compare to ignore case method, the current minimum value with whatever value is at the yth index. And if our minimum value is greater than this value, that means this has to be our new minimum value. Since this, if this right side returns, it's going to return -1, because if they're equal, it'll return 0. If this one's greater, it'll return 1, and if this one's greater, it'll return -1. If this is greater, our array min, whatever we stored in min value, if it's greater than whatever we are currently looking at, because we are constantly looking through our array until we have no more indexes. If we do this and we see that there's a value at a certain index, at index y, that is less than our current minimum value, we are going to set our new minimum value to be that yth index because we want to get the index. And then after we look at all of the values in our for loop, we're going to break out of it. But before we break out of our last for loop, we are going to go into our swap method. And our swap method is just going to switch the values at these indexes. It's going to swap the current minimum value with the current x value. So we can see here that whatever the xth index is, it's going to get swapped with the value at the min index. Once those two switch, and we do this for all of the values, it's going to be in order. And after we do that, we can just return the index, which will be the correct index for our current string s. And that is all of our methods. We're also asked to write a Javadoc for this, so we would have a name and author right here. We would also have a version number, and we can just put the date. And we have our variables listed. We have a constructor here, but we do need to say that it is the parameter capacity and then describe this as the length of the array. And here, this looks good. We're not returning anything. And here we are returning the string at index I. And then our next is we're taking the parameter s, and then it's going to return the position of the given value. And this is just a helper, but we have a parameter s, and that is the same thing right here. And we are returning the position of the given value as well, because this is our binary search. Now we're going to look at our sequential search. We are returning not the position, but a given value. And then we are going to return the position. And then for this one, we don't have any parameters, and we are just going to swap things after we sort things in here. So all of this looks good. Now we can test this. So if we go into our package and make a main, we can test this by writing SmartStringList and make an instance of it. Oh, we also have to pass in a parameter. So we're going to pass in, let's just make our length 9. We can do test, and we can see all of the methods. We have our get, our index of, sequential search, we have a sort, all of the methods that we wrote. We can call through here, we can add, and if we wanted to, we could even add more methods, but this is all that we are asked for. We don't necessarily want to have our swap and our sequential and binary searches public, because we are not asked for those in the rubric. So what we can do is we can actually make these private, so only this class can access it and not the main class. Our sort needs to be public, but this can be private as well. Lastly, we are going to make a Javadoc for it. We're just going to go into the hotbar up here and click project, then generate Javadoc. Click whatever one we're generating for, click finish, click OK, yes to all, and it will load our Javadoc. If you get errors, probably click this and look at it. We have no comments for this class, so we need to put one in. We can say that this is a class designed to make a list. And then if we click project, generate Javadoc again, and then click finish, okay, we should get this without any errors. After this, we can go into our Java project, click doc, and then we can see everything that we have in here. So we want to find our SmartStringList. This will be in our main and SmartStringList HTML. Once we open that, we can see our Javadoc and all of our methods inside of it.